Am I audible? Is audio video clear? Right. Yesterday we have discussed about properties of determinant and problems on determinant. 3-4 problems on determinants are there. First we will complete those problems. After that I'll be discussing a very important concept, rank of the matrix, how to calculate rank, what are independent vectors, what are dependent vectors. These are all okay. Now observe the problem. Matrix A is provided, adjoint of A is also provided. This is adjoint A. A is given and adjoint A is given. We have to find out the unknown value K. What is the value of K? Observe here. Yesterday I have explained you the concept. What is adjoint of A? Adjoint of A is nothing but transpose of cofactor matrix. Okay. Chandani, you can use the trick, but here you require only one entry, na? That's why I would like to solve by the concept. Okay, only one entry. That's why you can evaluate by using the concept. Now, K is in which place? Which place? K is in which place? Third row, second column. Right. K is 3-tooth element of adjoint of A. So third row, second column element of adjoint A. That's why you can write 2/3 element of cofactor matrix. Understood? Because when you compare cofactor matrix and adjoint A is nothing but transpose of cofactor matrix. That's why 3-tooth element of adjoint A become 2/3 element of cofactor matrix. Right. Now, this is nothing but cofactor of A23 of matrix A. That's why -1 whole power 2 plus 3 multiplied with its minor. Sir, how to get minor? Eliminating second row and third column from matrix A. Second row and third column from matrix A. What is left? If you eliminate second row and third column, what is left? 1 minus 2, 0, 5. That is nothing but -1 whole power 5 is -1. 5 minus 0. Finally, -5. Finally, -5. Understood? Next. If x is a1 minus a square plus a minus 1, 1 minus a, and x square plus x plus I equal to 0, then inverse of x is. Then inverse of x is. Observe here. They have provided one relation. By using that relation, we are going to find out inverse. X square minus x plus I equal to 0. It is not my assumption. It is given in the data. Now, you have to find x inverse. That's why I is equal to, you can write I is equal to x minus x square. Called it equation 1. multiply this equation on both sides with x inverse. I into x inverse equal to x into x inverse minus x square into x inverse. Understood? Now, x inverse equal to x into x inverse is I, x square into x inverse is x. So I minus x, you all know I means identity matrix, x is given in the data. Okay, now x inverse equal to I is 1001 minus x is matrix x is a1 minus a square plus a minus 1 minus a. Now calculate 1 minus a, you have to subtract corresponding entries. 0 minus 1, 0 minus of a square plus a minus 1 is a square minus a plus 1. 1 minus of 1 minus a. Understood? Therefore, 1 minus a minus 1. 1 minus a minus 1 is in first option and second option. Now, this is the correct answer. This is incorrect. Understood? Next problem. Matrix A is A11, A12, A21, A22. Matrix B is B11, B12, B21, B22. B2 matrices such that AB is equal to I, one relation. Another relation. C is equal to A into 1011. Next, third relation. CD equal to I. This is first condition. You have three conditions are provided. This is one condition. This is another condition. This is third condition. With the help of three conditions, we have to express D in terms of B. You have to express D in terms of B. Observe here. Concentrate. Given that CD equal to I. Sir, why you have taken CD equal to I? Why not AB equal to I? Why not C equal to A into 1011? I have to write D in terms of B. That's why I have taken first CD. Understand? Now, if CD equal to I, how to get D? You have to multiply with C inverse. C inverse from left. So C inverse into CD equal to CI. Concentrate. C inverse into C, identity matrix. C inverse into C, identity matrix. Abhishek, inverse I have taken to get D. Okay? Now, C inverse into CD equal to C inverse into I. C inverse into C, I into D. D equal to C inverse. Sir, how to get C inverse? They have given another relation. Where? Here. C equal to A1011. Okay, that's why I am going to write here A into 1011. That is C. For that C, I have to take inverse. Understood? Now, in matrix theory, we have one point. In matrix theory, PQ whole inverse is Q inverse into P inverse, na? That's why this can be written as 1011 ka whole inverse multiplied with A inverse. Okay. 1011 whole inverse into A inverse. Now our job is to calculate first 1011 whole inverse. How to get 1011 whole inverse? Yesterday I have explained you how to calculate inverse of a 2 cross 2 matrix. Okay. Now I am calculating here. Inverse of 1011. I should not write A. Some matrix. I'll keep like this. What is determinant? Suppose if I say matrix P, what is determinant? Determinant of P is 1 minus 0, 1. Now adjoint of P, adjoint of P. If matrix A is A, B, C, D, adjoint of A is D minus B minus C, A. 1, 1 here, 0 here, minus 1 here. Okay. Therefore, P inverse equal to adjoint P by det P. That is nothing but 1, 0 minus 1, 1, 1. Therefore, this equation can be written as, this equation is nothing but D na? D can be written as D is equal to 1011 whole inverse. 1011 whole inverse is 10 minus 11 into A inverse. 1 minute, observe. Given that AB is equal to I, if AB is equal to I, then B equal to A inverse. Okay. Now 101 minus 1 1 multiplied with A inverse. A inverse is nothing but B na. What is B? B is nothing but A inverse is nothing but B. B is nothing but B11, B12, B21, B22. Okay. Now multiply these two matrices. Automatically you will get B11 plus 0, B12 plus 0, minus B11 plus B21, minus B12 plus B22. Understood? Now clearly our matrix D is in terms of B. Understood? Completely the problem is designed on inverse concept. CD equal to I, D equal to C inverse. C is product of A and B, A and 1011. Okay, whole inverse. So PQ whole inverse property. After that, how to calculate inverse of 2 cross 2 matrix. After that, again AB equal to I. If AB equal to I, B equal to A inverse. Understood? Samiksha, for a 2 cross 2 matrix, adjoint A is D minus B minus CA. I have not written cofactor matrix here. Directly I have written adjoint A. This is a problem on concept of rank. Yes, Punjabi. That is called innovative thought. If AB is equal to I, CD equal to I, can you write AB equal to CD? Product of two matrices is identity matrix. All the matrices are equal. Now, it is a problem designed on concept of rank. So let me explain what is rank, how to calculate rank. Okay. Now, observe the definition. First, I am giving the definition. After that, I'll explain with the help of examples. Okay. Right. Rank of the matrix. The order of highest ordered, the order of highest ordered non-zero minor is called, the order of highest ordered non-zero minor is called rank of the matrix. The order of highest ordered non-zero minor is called rank of the matrix. What is the meaning of this minor? What is minor? The determinant value of square submatrix. The determinant value of square submatrix is called minor. By reading the definition, you won't get anything. I'll give the examples. What is submatrix? What is minor? How to select? Everything I'll explain with the help of example. Okay? Now, first read the definition once again. The order of highest ordered non-zero minor. The order of highest ordered non-zero minor is called rank of the matrix. Sir, if any matrix is given, how do I know that whether the minor is non-zero minor or not? No one knows. You can take one minor. Okay, you have to select. If you would like to find rank of any matrix, first you have to select one highest possible minor from the matrix. Expand. After expansion only, you will get the value. Whether the value is 0 or non-zero, you verify. If the value is non-zero, its order, whatever minor you have selected, order of that minor is rank of the matrix. Sir, if the matrix is 2 cross 3, 1, 3, 5, 2, 4, 6, 2 rows, 3 columns. If the matrix is 2 cross 3, what is highest possible minor? What is highest possible minor? I am not asking rank. Just I am asking what is highest possible minor? Possible minor. Sir, what is minor? Determinant value of square submatrix. Sir, what is submatrix? If you eliminate a row or column or rows or columns from the matrix, you can generate one submatrix. By eliminating first column, you can get one submatrix. By eliminating first column, you will get 3, 5, 4, 6. That is one submatrix. Suppose by eliminating second column, you can get one submatrix. By eliminating third column, you can get one submatrix. By eliminating complete first row, you can get one submatrix. So many submatrices you can get, but I require only highest possible square submatrix. What is highest possible? You have two rows. If you have two columns, then you can generate one square submatrix. So 2 cross 2 square submatrix is the highest possible square submatrix in this problem. Sir, there are so many 2 cross 2. Yes, you have 3 2 cross 2. You can take any 2 cross 2. At least one 2 cross 2 minor is non-zero. Rank is 2. Observe. 18 minus 20. 18 minus 20. Value is minus 2. We are not interested about what is the value. We are interested about whether the value is non-zero or zero. Minus 2 is non-zero or zero? Non-zero. If the highest possible minor is non-zero, rank is its order. Its order is 2. Its order is 2. Therefore, rank is 2. A 2 cross 2 minor is non-zero. Therefore, rank of A is 2. Okay, that is the definition. Generally, students' thought process is, sir, if it is non-zero, rank is 2. Okay. Suppose if it becomes 0, what we have to do? I am coming to that. Okay. First, let me explain the basic definition. Do you understand this? I'll give another example. Next, I will come to if it is 0, what? Okay. Now, for example, matrix A is 3 cross 4. 3 cross 4. If matrix A is 3 cross 4, Sarthak, you wait. Let me explain. At the first example, so many questions is difficult to answer. If you understand the concept, first you fix the concept. Next, automatically your doubts will be clarified. Now, come here. Matrix is 3 cross 4. If the matrix is 3 cross 4, suppose 1, 1, 1, 1, 1, 2, 3, 4, 3, 1, 2, 5. For example, matrix is 3 cross 4. Sir, what is highest possible minor? What is highest possible minor? 3 cross 3. Sir, how 3 cross 3 is highest possible minor? Maximum number of rows are 3, but maximum number of columns are 4. But you can't generate 3 cross 4. Okay, because minor matlab it must be a square matrix. So what is highest possible square matrix? 3 cross 3. Sir, shall I write 4 cross 4? You have 4 columns. Introducing your own rows are not acceptable. From the given matrix only you have to generate. Okay, that's why maximum possible square matrix is 3 cross 3. So maximum possible minor is 3 cross 3. Select any 3 cross 3. Sir, how many 3 cross 3 are available here? Simple logic. How many 3 cross 3 minors are available here? Very simple, very simple. You require 3 cross 3. 3 cross 3 matlab 3 rows, 3 columns. Na? How many rows are available? How many rows are available? 3 rows. From 3 rows, you have to select 3 rows. How many ways? 3C one way. Okay. Sorry, 3C3. From 3 rows, you have to select 3 rows. From 4 columns, you have to select 3 columns. 4C3. 3C3 is 1. 4C3 is 4. 4 into 1 is 4. So finally, you can generate 4 3 cross 3 minors. 4 3 cross 3 minors. How? Eliminate first column, 1 minor. Eliminate second column, 1 minor. Eliminate third column, 1 minor. You can generate. Eliminate fourth column. You can generate 1 3 cross 3 minor. Like that, you can generate 4 3 cross 3 minors. Sir, shall I check all 4 3 cross 3 minors? You need not to check all 4 3 cross 3 minors. You have to check only one. If it is non-zero, your job is over. Suppose if it becomes 0, then only we have to select other minor. That's my point. Now select 1 3 cross 3 minor. Verify its value. 1 1 1 1 2 3 3 1 2. Now 1 of 4 minus 3 minus 1 of minus 1 of 2 minus 9 plus 1 of 1 minus 6. 4 minus 3 is 1. 2 minus 9 is minus 7. Minus 7 into minus 1 plus 7 minus 5. That is 8 minus 5, 3, non-zero. If the value is non-zero, then rank is its order. Rank of A is 3. Understood? Rudra, I am coming to that. Simple logic. If your matrix is M cross N, select minimum of M comma N. If the matrix is M cross N, select minimum of M comma N. The minimum of M comma N is the highest possible minor. Suppose your matrix is 3 cross 20. So select minimum of 3 comma 20. 3. Therefore, you can understand that 3 cross 3 matrix is the highest possible minor. Select 3 cross 3. Sir, first 3 cross 3 is 0. Verify other 3 cross 3. Sir, that is also 0. Verify next 3 cross 3. At least one 3 cross 3 minor is non-zero. Rank is 3. Sir, all 3 cross 3 minors are 0. Then what I have to do? If all 3 cross 3 minors are 0, then only you have to verify 2 cross 2. If all 3 cross 3 minors are 0, then we have to check 2 cross 2. If all 3 cross 3 minors are 0, then only we have to check 2 cross 2. Otherwise, at least one 3 cross 3 is non-zero, rank would be 3. If all 3 cross 3 minors are 0, then you have to check 2 cross 2. Catch my point? Suppose at least one 2 cross 2 is non-zero, rank would be 2. Suppose if all 2 cross 2 are also 0, then rank would be 1. Like that. मानिक चौधरी थोड़ा सोचना पड़ेगा आपने. Minimum of 3 comma 2 is 20 is 3. Why not 2? How it will become 2? Minimum का भी minimum of 3 comma 20 दोनों से minimum 3 is the minimum. Now, observe. Do you understand this procedure? Now I am taking 3 cross 3. Matrix A is, for example, another example, 1 1 1 1 2 3 2 3 4. Matrix is 3 cross 3. Observe. Observe here. Iqbal, nothing is tough. Only the thing is you have to understand maths. First understand, fix the concepts, then start practicing. Mathematics requires only practice. Fix the concepts, learn, then practice. Okay? Concentrate here. Matrix is 3 cross 3. Matrix is 3 cross 3. Highest possible minor is, tell me, highest possible minor. Minimum of 3 comma 3 is 3. That's why you 3 cross 3 minor is highest possible minor. Now, observe 1 of 8 minus 9 minus 1 of 4 minus 6 plus 1 of 3 minus 4. Now, minus 1 plus 2 minus 1, 0. Okay, a 3 cross 3 minor is 0. A 3 cross 3 minor is 0. Okay, a 3 cross 3 minor is 0. If a 3 cross 3 minor is 0, you have to select other 3 cross 3. Is it available? Is it available? Is any other 3 cross 3 is available? Not available. If it is not available, then only we have to move to 2 cross 2. Verify 2 cross 2. Sir, how many 2 cross 2 we have? 3C2, 3C2. So 3 into 3, 9. 9 2 cross 2 minors are available. You need not to check all 9. You have to check 1. At least 1 2 cross 2 is non-zero. At least 1 2 cross 2 is non-zero. Rank would be 2. Okay? Now, verify 2 cross 2. 1 1 1 2. That is 2 minus 1, 1 non-zero. A 2 cross 2 minor is non-zero. Therefore, rank of the given matrix is 2. Understood? Rank of the given matrix is 2. Understood the definition? So, rank is nothing but the order of highest ordered non-zero minor. Kamlesh, I will come to the operations later. I am explaining in a sequence wise. Okay? So, please understand. Please understand. Whenever you would like to find rank of any matrix, first you have to select highest possible minor. Verify whether the value is 0 or non-zero. Just by one glance you can't say. After expansion only you will get. If you expand it, you will get the value. If the value is non-zero, rank is its order. Whatever minor you have selected, order of that minor, order of that non-zero minor is called rank. Okay, right. Next, Pallavi, what is the use of rank? So what is rank? If you understand what is rank, you can understand what is the use of rank. Rank always declares number of independent vectors. Sir, what are independent vectors? Again one question. Sir, what are dependent vectors? Another question. That's why you have to wait till I am going to explain linearly independent vectors, dependent vectors. At the end of the class, you will get the clarity. Okay? Now, observe. Properties of rank. The rank of null matrix rank of null matrix is taken as 0. Rank of null matrix is considered as 0. Rank of null matrix is taken as 0. Next, if the matrix is null matrix, rank is treated as 0 or rank is considered as 0 or rank is taken as 0, right? The rank of non-singular matrix is its order. Sir, why its order? Rank of non-singular matrix is its order. What is the reason? Janki, determinant non-zero. Yes, determinant is non-zero. Please remember, determinant is the highest possible minor here. The determinant is the highest possible minor because our matrix is square matrix now. If the matrix is square matrix, highest possible minor is, if the highest possible minor is non-zero, rank is its order. Simple. Sir, why determinant is non-zero? It is non-singular matrix now. The definition of non-singular is determinant non-zero. That's why highest possible minor is non-zero. If highest possible minor is non-zero, rank is its order. Same question you have, previous gate question. Observe in 94. For a matrix, rank equals to both number of rows and number of columns. Which one of the following? Any matrix has rank equal to number of rows equal to number of columns is nothing but non-singular, non-singular matrix based on this property. Okay, next. Sir, rank of non-singular is its order. Okay, rank of non-singular is its order. What about rank of singular matrix? What about rank of singular matrix? Rank of singular matrix is less than its order or greater than its order or equal to its order. Which one? less than its order. Sir, why less than its order? Why not greater than its order? Rank never be greater than its order. Okay, because you are going to take highest possible minor. That's why rank never exceed its order. Rank is either equal to its order or less than its order. But in the case of singular matrix, determinant is zero. Na? If determinant is zero, what is rank here? 2. 2 is less than its order or not? Order 3, but rank is 2 because determinant of 3 cross 3 is 0. So, in the case of singular matrix, determinant rank is less than its order. The reason is determinant is 0. Determinant 0 means highest possible minor 0. When highest possible minor is 0, rank must be less than its order because you are going to take next minor. That's why. Next property. If A is M cross N matrix, if A is M cross N matrix, then rank of A less than or equal to minimum of M comma N. If A is M cross N matrix, then rank of A less than or equal to minimum of M comma N. Simple. Suppose your matrix is 3 cross 100. Even though you have 100 columns, but number of rows are only 3. Because number of rows are 3, maximum possible minor is 3 cross 3. That's why maximum possible rank is 3. Understood? That's why you have to take minimum of 3 comma 100 is 3 na? Minimum of 3 comma 100 is 3 na? That's why rank of A is less than or equal to 3 because maximum possible minor is 3 cross 3. Since maximum possible minor is 3 cross 3, maximum possible rank is 3. That's why rank of A is less than or equal to 3. That's why you can say that rank of A is less than or equal to minimum of M comma N. Understood? Next property. In a matrix, if all the rows means all the columns also. The property is applicable for rows as well as columns. Okay. So in a matrix, if all the rows are identical or proportional, then its rank is always 1. Its rank is always 1. One point I have to clarify. In this property, while reading this property, some student, I will give the example. Wait, Rashmi. Let me explain. One point you have to remember here. Sir, yesterday we have one property. Sir, 2 rows are identical. Determinant value is 0. Surabhi has posted same point. Please remember. Yesterday's property is different. This property is different. 2 rows are identical, determinant is 0. Determinant 0 gives us only rank less than its order, not rank 1. Here, main keyword is all. All the rows Yesterday's property was two rows are identical or two rows are proportional, determinant is 0. Here, all the rows are identical or all the rows are proportional, then rank is always 1. Don't get confused. This property is different, that property is different. There, two rows are identical, determinant is 0. If determinant is 0, matrix is singular. If matrix is singular, rank is less than its order. Here, all the rows are identical, all the rows are proportional, or all the columns are identical, all the columns are proportional, then rank is always 1. Example. For example, matrix A is 1, 2, 3, 2, 4, 6, 3, 6, 9. Soras, observe the entries. First row 1, 2, 3. Second row is nothing but 2 times of first row. Third row is nothing but 3 times of first row. Okay, they are proportional. First row, if you say alpha, second row is 2 alpha, third row is 3 alpha. So whenever all the 3 rows are proportional, all the 3 rows are proportional, all the rows are proportional, rank of A is 1. I'll explain you simple technique. Sir, how do we know that whether the rows are proportional or not? Simple technique I am giving. You verify all 2 cross 2 minors like this. Like this you verify. 4 minus 4, 0. 12 minus 12, 0. 12 minus 12, 0. 36 minus 36 are 0. Therefore, 100% all the rows are proportional. You can say that rank is 1. If your matrix consisting of all the rows are proportional, 100% all your 2 cross 2 minors are going to become 0. Understood? Next, observe this problem. Previous year gate question, last year not 96. Observe the rank of n plus 1 cross n plus 1 matrix where A is a real number. All the rows are identical. All the rows are identical. If all the rows are identical, then rank is 1. Next property. Next property. Mahendra Yadav, I already clarified. If two rows are identical, rank is less than its order. That property is different. This property is different. Don't get confused. Don't confuse others. If two rows are identical, determinant is 0. If determinant is 0, rank is less than its order. If all the rows are identical, rank is 1. Next point, next property. Rank of A transpose, rank of A into A transpose, rank of A transpose into A are always same. There is no lag. Refresh your system. Murali, refresh your system. Please refresh your system. Come to the point. Rank of A transpose, rank of A into A transpose, rank of A transpose into A are always same. Observe the example. Janaki, you have to understand the property properly. I said rank of A transpose. Did I said A is a square matrix? That's why we are not talking about determinant here. Rank. Determinant exists only when matrix is square, but rank exists for any matrix, whether it is square matrix or rectangular matrix. Okay, I'll give the example. Just observe. X is 3 cross 1. X transpose is automatically 1 cross 3. Okay, now 1 3 5 1 3 5. X is 3 cross 1 matrix. What is highest possible minor? 1 cross 1. What is rank of X? 1. X transpose. What is highest possible minor of X transpose? 1 cross 1. 1 cross 1 minor is non-zero. So rank is 1. So rank of X is 1. Rank of X transpose is 1. Because in X and X transpose, maximum possible minor is 1 cross 1. That 1 cross 1 minor is non-zero. That's why rank is 1. Okay? Observe now. Sir, if you multiply X with X transpose, 3 cross 1 multiplied with 1 cross 3, result is 3 cross 3. Sir, in the previous case, I mean, in the case of X and X transpose, you have only 1 cross 1 minor. That's why you said rank is 1. Now here, X into X transpose is a 3 cross 3 matrix. Yes, 3 cross 1 multiplied with 1 cross 3, you will get a 3 cross 3 matrix. 1 with 1, 1, 1 with 3, 3, 1 with 5, 5, 3 with 1, 3, 3 with 3, 9, 3 with 5, 15, 5 with 1, 5, 5 with 3, 15, 5 with 5, 25. Even though it is 3 cross 3, but rank is 1 because all the rows are proportional. All the rows are proportional. That's why rank of X into X transpose equal to 1. That's why rank of A is 1, rank of A transpose is 1, rank of A into A transpose is 1, rank of A transpose into A is 1 in this example. In this example. Okay. In this example, it is 1. Not in every problem, it is 1. In some other problem, rank of A is suppose 10, rank of A transpose is also 10. Rank of A into A transpose is also 10. Rank of A transpose into A is also 10. Like that. Understood? Depending on your matrix. 1 minute, observe. Observe this problem. Observe this problem. Matrix A is a 1 less than or equal to I comma j less than or equal to n, means n cross n matrix. A I j equal to I into j for all I j. Then what is rank of A? Observe. A is n cross n. A I j equal to I into j for all I j. Okay, observe. A11, A12, A1n, A21, A22, A2n, AN1, AN2, ANN. Avdesh, they have given clearly 1 less than or equal to I comma j less than or equal to n. Means I varies from 1 to n, j varies from 1 to n. That's why you will get n cross n. Come here. Now, multiply. Observe A11, Aij equal to I into j na? 1 into 1, 1. 1 into 2, 2. 1 into n, n. 2 into 1, 2. 2 into 2, 4. 2 into n, 2n. N into 1, n. N into 2, 2n. N into n, n square. All the rows are proportional, or all the columns are proportional. Therefore, rank of A is 1. Understood? Observe here. Rank of 3 cross 3 matrix C equal to AB found by multiplying non-zero columns of A. Concentrate. Non-zero columns of A 3 cross 1, non-zero rows of B 1 cross 3. Then what is rank of 3 cross 3? Non-zero columns of A 3 cross 1, non-zero rows of B 1 cross 3. Then what is rank of C? 1. That example only I have given. 3 cross 1 multiplied with 1 cross 3, result is 3 cross 3. Therefore, rank becomes 1. Okay? Next property. Next property. Rank of AB less than or equal to, Surabhi, I am coming. Let me explain properties. I am coming to the property. I am coming to the problems later. Rank of AB less than or equal to minimum of rank of A comma rank of B. Rank of AB less than or equal to minimum of rank of A comma rank of B. For example, A is 3 cross 5. B is 5 cross 7. A is 3 cross 5, B is 5 cross 7. Tell me, what is maximum possible rank of A? What is maximum possible minor? 3 cross 3 na? What is maximum possible minor here? 5 cross 5 na? What is maximum possible rank of A? I am talking about maximum possible. Maximum possible rank of A is 3. Maximum possible rank of B is 5. So please remember, maximum possible rank of A is 3, maximum possible rank of B is 5. So finally, maximum possible rank of AB would be 3 only. Understood? Multiply A with B. 3 cross 7. What is maximum possible minor? 3 cross 3. Therefore, maximum possible rank of AB less than or equal to, as per the property, minimum of maximum possible rank of A, maximum possible rank of B, that is rank of AB less than or equal to 3. Understood? So rank of AB less than or equal to minimum of rank of A comma rank of B. Next, rank of A plus B less than or equal to rank of A plus rank of B. Rank of A plus B less than or equal to rank of A plus rank of B. The rank of a diagonal matrix, rank of a diagonal matrix is equal to the number of not order, non-zero diagonal entries. Sir, what is diagonal matrix? All off diagonal entries of a square matrix are zero. That is known as diagonal matrix. If off diagonal entries are zero, diagonal entries decides the rank. In the diagonal entries, how many non-zero diagonal entries? That number is rank of the matrix. So the rank of diagonal matrix is equal to number of non-zero diagonal entries. Non-zero diagonal entries. Example, D, diagonal matrix D is 3, 6, 0, 0, 0, 0, 0, 0, 0. When we will say matrix is diagonal matrix, all non-diagonal entries are 0. Yes, all of diagonal entries are 0. Okay, sir, what is rank here? How many non-zero entries in the principal diagonal? Only 2. That's why rank of D is 2. Directly you can say. Rank of D is 2. Number of non-zero diagonal entries is called rank of the diagonal matrix. Don't forget this keyword. If the matrix is diagonal matrix, then only this logic is applicable, not for every square matrix. If your matrix is a diagonal matrix, then only you have to count number of non-zero diagonal entries. Next, 3 properties. All 3 properties are looking like similar, but there is a variation. If A is a square matrix of order n or an n cross n matrix, if A is n cross n matrix with rank n, then rank of adjoint A is also n. If A is n cross n matrix with rank n minus 1, then rank of adjoint A is 1. If A is n cross n matrix with rank n minus 2, then rank of adjoint A is 0. Sir, A is n cross n matrix. In all the cases, A is n cross n matrix. First case, rank of A is n. rank of adjoint A is n. Second case, rank of A is n minus 1, rank of adjoint A is 1. Rank of A is n minus 2, rank of adjoint A is 0. Sir, suppose rank of A is n minus 3, then rank of adjoint A 0 only. Okay, rank never be negative. Rank is 0 only. In the case of A is n cross n matrix with rank n minus 2 or less than n minus 2, rank of adjoint A would be 0. Okay, right. I would like to give the example. For first property, matrix A is, I am taking only simple 2 cross 2. 3, 5, 2, 7. For example, what is adjoint A? Adjoint A, D minus B minus C A minus B minus C. What is determinant value of A? 21 minus 10, 11. Determinant value of adjoint A, 21 minus 10, 11. Non-zero, non-zero. What is rank of A? 2. Rank of adjoint A is also 2. Matrix is 2 cross 2 with rank 2. Rank of adjoint A is also 2. Second example, 3 cross 3. Observe second example. Matrix A is 1, 1, 1, 1, 2, 3, 2, 3, 4. Now, det A is, matrix is 3 cross 3. What is det A? Det A, 1 of 8 minus 9 minus 1 of 4 minus 6 plus 1 of 3 minus 4 minus 1 plus 2 minus 1, 0. Det A is 0. If det A is 0, next you have to verify. If 3 cross 3 minor is 0, you have to verify 2 cross 2. So 2 cross 2. 1, 1, 1, 2. 2 minus 1, 1. Non-zero. Non-zero. If 2 cross 2 minor is non-zero, rank is 2. Matrix is 3 cross 3 with rank 2. Matrix is 3 cross 3 with rank 2. If your matrix is n cross n with rank n minus 1, same property, na? Rank of A is n minus 1. N cross n matrix with rank n minus 1. Then rank of adjoint A is 1, not n minus 1. 1 only. I am going to explain. First, I have to calculate adjoint A. Yesterday, I have explained you one technique. Trick to write adjoint of A. Middle last, first middle. Remember? No problem. Again, I am explaining. Middle, last, first, middle. From middle column, middle element, write the entries clockwise. 2, 3, 1. 2, 3, 1. Next, last, 3, 4, 1. Next, first, 1, 2, 1. Next, middle, 2, 3, 1. Repeat first column. Repeat first column. 2 3 1 2 2 3 1 2. Now apply AD minus BC technique, automatically will get adjoint A. 8 minus 9, 8 minus 9 minus 1, 3 minus 4 minus 1, 3 minus 2 1, 6 minus 4 2, 4 minus 2 2, 1 minus 3 minus 2, 3 minus 4 minus 1, 2 minus 3 minus 1, 2 minus 1 1. Now verify all the rows. All the rows are proportional or identical. Therefore, rank of adjoint A is 1. Understood? Abhishek, don't divert the property. Understand the property clearly. I said clearly, matrix is n cross n with rank n minus 1. Rank of adjoint A is 1. Not less than n minus 2. 1. 100% 1. If A is n cross n with rank n minus 1, rank of adjoint A is 1. Understood? Suppose if you take n cross n matrix with rank n minus 2, rank of adjoint A will be 0. I am not giving any example, just remember. Next, suppose you would like to take one example. Let us take, instead of adjoint A, let us take this matrix as A. Rank is 1. Calculate adjoint A. You will get null matrix. That's why just remember the property. If A is n cross n with rank n minus 2, rank of adjoint A is automatically 0. Next. Another method to calculate rank of the matrix. Sir, already you have explained one method. Why another method is required? This method, this minor approach is, you can apply up to 3 cross 3 and 3 cross 4. Okay. Suppose your matrix is 5 cross 6. 5 cross 6. Suppose if the given matrix is 5 cross 6, what is the highest possible minor? 5 cross 5. You have taken one 5 cross 5. Actually, there are 6 5 cross 5. You have taken one 5 cross 5. You have expanded. Actual expansion of 5 cross 5 consumes time. You have expanded. Okay. Suppose, luckily, if it is 0, I mean, after expansion, if the value is non-zero, then rank is 5. If it becomes 0, you have to verify other 5 cross 5. That's why whenever matrix is of higher order, minor approach is not preferable. Not preferable means, sir, will I get wrong answer? You won't get wrong answer. It consumes time. In competitive examination, that method is not preferable. Not preferable. That's why the best method to calculate rank of the matrix is echelon form or triangular form. Okay, I'll explain triangular form. First, I am giving the points of triangular form. What are the necessary conditions of triangular form? When we can say that a matrix is an echelon form, if it satisfies two conditions. What are the two conditions? First, I am giving those two conditions. Okay. Just you note down. After that, I'll explain. I said minor approach is not preferable for higher order, not for 3 cross 3. You can use for 3 cross 3, no problem. Echelon form or triangular form. First one. The number of zeros before non-zero element in a row are less than such a number of zeros in the next row. The number of zeros before non-zero element in a row are less than such a number of zeros in the next row. Zero rows, if any, must follow non-zero rows. The number of zeros before non-zero element in a row are less than such number of zeros in the next row. Zero rows, if any. If you have any zero rows, they must follow non-zero rows. These are the two conditions. First condition is designed for non-zero rows. Second condition is designed for zero rows. I mean, first condition you should not apply on zero rows. Second condition you should not apply on non-zero rows. First condition is for non-zero rows. Second condition is for zero rows. The number of non-zero rows is called rank of the matrix. I have mentioned clearly rows. You are asking columns. Let me fix the concept. I am talking about row echelon form. In row echelon form, you have to apply completely row operations. Did I have mentioned anywhere columns? Rishabh? There are two types of echelon forms. One is row echelon form, another one is column echelon form. 90% of entire matrix theory is depending on row echelon form. System of equations, eigenvalue problems, all the problems you are going to discuss on row echelon form. For rank, better to go for row echelon form. Okay? Now, observe. I would like to explain these 2 points by taking 2-3 examples. For example, matrix A. Mr. Yadav, R is for rank, R is for rosa. Did you define or someone has defined? Row, not R. Row. Row is rank. Standard symbol. That is row. Now, 2, 3, 0 7 0 5 9 6 0 0 5 minus 1 0 0 0 0. Next example, B, matrix B. 9 1 2 3 0 0 6 9 0 0 0 3 0 0 0 0 0 0 0 0. 197 036 0010. Consider here. Suppose matrix D 1527 0013 0006. Now, what is our first condition? The number of zeros, concentrate here, the number of zeros before non-zero element, before non-zero element means you have to count this type of zeros before non-zero element. 1 0 before non-zero element, 2 zeros before non-zero element. You have to count such type of zeros. Okay, not this type of zero. Sir, this is before non-zero element. Not only before non-zero element, but also after non-zero element. Don't count such type of zeros. Always you have to count number of zeros before non-zero element in a row are less than such number of zeros in the next row. Means whenever you are moving from R1 to R2, R2 to R3, R3 to R4, previous row should consist lesser number of zeros than present row. Sir, simply we can say number of zeros before non-zero element should be in ascending order. Yes, ascending order. Okay. First row, there is no zero before non-zero element. Second row, 1 0 before non-zero element. Third row, 2 zeros before non-zero element. No 0, 1 0, 2 zeros before non-zero element in non-zero rows. Only in non-zero rows you have to count number of zeros before non-zero element, whether they are increasing or not. That is our first condition. If they are in increasing order, it satisfies first condition. Sir, what about second condition? 0 rows. Within bracket I have mentioned if any. If you have any 0 rows, that 0 row must appear last. Sir, in my problem there is no 0 row, no problem. If you have any 0 row, that 0 row must appear last. Come here. There is a 0 row. 0 row is appeared last or not? 0 row is appeared last. Number of zeros before non-zero element are in ascending order. Therefore, matrix A is in echelon form. Sir, what is rank? Number of non-zero rows is called rank. How many non-zero rows you have? How many non-zero rows you have? 3. 3. Therefore, rank of A is 3. Next, observe second example. So finally, conclusion is in 0 rows, you have to check whether 0 rows are appeared last or not. Whether 0 rows are appeared last or not. Kushbu, I already told you don't count zeros in 0 rows. You have to count zeros in non-zero rows, not in 0 rows. Second condition is You have to check 0 rows are appeared last or not. Here you have 2 0 rows. Both the 0 rows are appeared last. Sir, what is first condition? Number of zeros before non-zero element should be in ascending order. Here no 0. Here 2 zeros. No 0, 2 zeros. Increasing or not? 3 zeros. Increasing or not? Sir, no 0, 2 zeros, 3 zeros. 100% increasing. No zeros, 2 zeros, 3 zeros. Increasing order. Whenever number of zeros before non-zero elements are in increasing order, you have to check 0 rows are appeared last or not. Clearly 0 rows are appeared last. It is in echelon form. In echelon form. Therefore, rank of B is 3. Mr. Rudra, I have given the point very clearly. Number of zeros before non-zero element should be in ascending order. Sir, if 2 rows give same number of zeros before non-zero element, then what we have to do? You have to apply next operation. It is not in echelon form. Okay? Now, third one, matrix C. There is no 0 row, no problem. That's why I have mentioned if there is any 0 row, then it must follow. If there is no 0 row, no problem. Here, no 0, 1 0, 2 zeros. Increasing or not? Increasing. Therefore, rank of C is 3. Understood? Now, observe D, matrix D. No 0, 2 zeros, 3 zeros. Ascending or not? Therefore, rank of D is 3. Not completed. Just I have explained these 2 points with the help of these 4 examples. Okay. Now, actual examples I am explaining now. If you have any queries on this echelon form concept, you can ask me after 4th example. Till that, you have to observe how I am solving the problem. All your doubts will be clarified if you look at all these 4 examples. Matrix A. Matrix A. 1, 2, 3, 0. 3, 2, 1, 3, 2, 4, 3, 2, 6, 8, 7, 5. 1, 2, 3, 0, 3, 2, 1, 3, 2, 4, 3, 2, 6, 8, 7, 5. Now, is it in echelon form? Mr. Vineet, you have to wait. One, 2, 3, 0, 3, 2, 1, 3, 2, 4, 3, 2, 6, 8, 7, 5. It is not in echelon form. It is not in echelon form. We have to reduce into echelon form by using sortable operations. Okay? Consider. I am explaining one technique. First, to verify 1th element is 0 or non-zero. 0 or non-zero. Verify. Non-zero na? If it is non-zero, the trick is applicable. Sir, what is the trick? Select a right angle triangle. Just form a right angle triangle which covers 1 element in 2nd row, 2 elements in 3rd row, 3 elements in 4th row. Form a right angle triangle which covers 1 element in 1st row, 2 elements in 2nd row, 3 elements in 4th row. Whenever 1th element is non-zero, 1th element is non-zero, 1st row, 1st column entry is non-zero, Start a right angle triangle from second row. Apply the operations. Please apply row operations. Echelon form is restricted to only one set of operations. Only one set of operations. Either you have to apply completely row operations or you have to apply completely column operations. My discussion is row echelon form. You have to apply row operations only. Observe. Sir, what I have to do with this right angle triangle? You have to reduce all the entries in the right angle triangle as 0. Sir, what is the advantage of this technique? Is it compulsory? The technique is only for convenience. If you reduce all the entries covered by right angle triangle 0, it automatically satisfies first condition of our echelon form. Now, R2 minus 3 times of R1, R3 minus 2 times of R1, R4 minus R1 plus R2 plus R3. Concentrate here. First row, there is no operation, write as it is. Second row, you have to apply this operation. R2. R2 matlab old R2 minus 3 times of old R1, right? New R2. Okay? Now, 3 minus 3, 0. 2 minus 6, minus 4. 1 minus 9, minus 8. 3 minus 3 into 0. 3 minus 0, 3. Next. R3 minus 2 times of R1. This is R3. This is 2 times of R1. Now observe. 2 minus 2, 0. 2 minus 2 is 0. 4 minus 4, 0. 3 minus 6, minus 3. 2 minus 0, 2. Next. Fourth row, R4 minus R1 plus R2 plus R3. 6 minus 6, 0. 8 minus 8, 0. 7 minus 7, 0. 5 minus 5, 0. Okay. Now look at the resultant matrix. Look at the resultant matrix. First row, no 0. Second row, 1 0. Third row, 2 zeros. Number of zeros before non-zero element are in increasing order or not? Clearly increasing. Now 0 row is appeared last. Therefore, rank is number of non-zero rows 3. Therefore, rank of A is 3. Understood? Observe next example. Some students have some queries. They are mentioning the comment box. Please observe 4 examples. After 4th example only, I will look at the comment box. Till the time your concentration should be on these examples only. All your doubts will be clarified. Now, very simple. Matrix A is 4 cross 4. From First row, first column. If 1, 1, 10, 3 is non-zero, start a right angle triangle from second row. In second row, it covers only one element. Third row, it covers two elements. Fourth row, it covers three elements. Okay? Now, reduce all the elements covered by right angle triangle 0 by using elementary operations. If it satisfies both the conditions of echelon form, count number of non-zero rows. Rank is 3. Next example. Next example. One zero 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 0100 2101 0001. Now, first verify 1th element is 0 or non-zero. Non-zero. That's why start a right angle triangle from second row onwards. In second row, it covers one element. Third row, it covers two elements. Fourth row, it covers three elements. Reduce all the elements covered by right angle triangle 0. Observe. R3 minus 2 times of R1. 1 0 0 0 0 1 0 0. Now R3 minus 2 times of R1. 2 minus 2 0. 1 minus 0 1. 0 minus 0 0. 1 minus 0 1. Next R4 0 0 0 1. Now verify whether it is in echelon form or not. First row, before non-zero element, no 0. Second row, 1 0. Third row, again 1 0. Equal number of zeros. Because of equal number of zeros in R3 and R2, it is not in echelon form. Next, apply the operation. R3 minus R2. Continuation. 1 0 0 0 0 1 0 0 0 R3 minus R2 na third row minus second row 0 minus 0 0 1 minus 1 0 0 minus 0 0 1 minus 0 1. Fourth row you have to write as it is 0 0 0 1. Now verify. Is it in echelon form? Is it in echelon form? Sir, how to check? Verify number of zeros before non-zero element are in ascending order or not. 1 0. Here no 0. Here 1 0. Here 3 zeros. Again here 3 zeros. Understood? Third row and fourth row. When you compare third row and fourth row, number of zeros before non-zero element are same. 0001, 0001. That's why it is not in echelon form. 1 minute, observe. Sir, all the elements covered by right angle triangle are 0. You said if you reduce all the elements covered by right angle triangle are 0, it is in echelon form. I never said. I said if you reduce all the elements covered by right angle triangle 0, it satisfies first condition of echelon form. I said. Catch my point? That's why, sir, all the elements covered by right angle triangle 0, can we say the matrix is in echelon form? You can't say. You have to check one by one, step by step, whether it is satisfying the condition or not. Even though all the elements covered by right angle triangle 0, you have to check first condition as well as second condition. So here your matrix is not in echelon form because R3 and R4 consisting same number of zeros before non-zero element. That's why you have to apply the operation R4 minus R3. Now verify number of zeros before non-zero element are in ascending order or not in non-zero rows. Zero row is appeared last or not. Therefore, it is an echelon form. Number of non-zero rows are 3. Therefore, rank of A is 3. Understood? Rank of A is 3. Next example. Matrix A is 0, 1, 2, 1, 1, 3, 1, 3, 7, 1, 5, 11. Okay. Now, observe. 1th element is 0. No problem. You can reduce 1th element as non-zero by interchanging R1 into R2. 1, 1, 3, 0, 1, 2, 1, 3, 7, 1, 5, 11. Verify. Here, form a right angle triangle. It covers 1 element in second row, 2 elements in third row, 3 elements in fourth row. Now tell me, is it in echelon form? Is it in echelon form? No. Apply the operations. R3 minus R1, R4 minus R1. One minus 1, 0. 3 minus 1, 2. 7 minus 3, 4. 1 minus 1, 0. 5 minus 1, 4. 11 minus 3, 8. Now, tell me, is it in echelon form? No. Because number of zeros before non-zero element are 0, 0, 0. Equal. It is not satisfying the condition. That's why apply the operation. R3 minus 2 times of R2. R4 minus 4 times of R2. Zero, 0, 0, again 0, 0, 0. Number of zeros before non-zero element. No 0, 1, 0. Here no 0, here 1, 0. Increasing order. 0 rows are appeared last. How many number of non-zero rows? 2. Therefore, rank of A is 2. Any queries? Any innovative thoughts on echelon form? Understood? Now, sir, what is rank? So, what is rank? You understood very well. So, what is rank? Till now, I have explained only the procedure to find out rank. One procedure is minor approach, another procedure is echelon form approach. I have not explained you what is rank. I have explained you how to calculate rank. The order of highest ordered non-zero minor is called rank. What is that? It is a procedure to calculate rank. Echelon form, two conditions. If the matrix satisfies both the conditions of echelon form, number of non-zero rows is called rank. What rank represents? Please remember, rank represents number of independent vectors. Sir, what is independent vector? 1 minute, observe. I'll explain. Observe here. X1, X2, 1, 3. X2 is 6, 18. Now, tell me, X2 and X1 are independent or dependent? The vector X1 and X2, column vector. X1 is one column vector, X2 is another column vector. X2 and X1 are dependent or independent? Dependent. How do you know that? Any vector is possible to express some scalar multiplication of other vector. Any vector is possible to express scalar multiplication of other vector, you can say that they are dependent. LD matlab linearly dependent. Okay. Now observe, this is one example. Another example, for example, X1 is 1, 3, X2 is 1, 2. Tell me now, is it possible to express second vector as some scalar multiplication of first vector, or first vector is scalar multiplication of second vector? Not possible. X2 cannot be possible to write k times of X1. Therefore, X1 and X2 are linearly independent. Himanshu, understand the concept properly. Did I said X1 is independent? I never said X1 is dependent. That's why please understand the concept properly. I said X1 and X2 are dependent. Here I have mentioned X1 and X2 are independent. If any vector is possible to express some constant into other vector, or combination of two vectors gives third vector, if linear combination is possible, then you can say that they are dependent. If it is not possible, then they are independent. Okay, observe the definition. Linearly dependent and independent vectors. Actually, to examine whether the vectors are linearly independent or dependent, you have four methods. Four methods. Just I have explained one simple method. Okay, I'll explain all four methods. Two vectors X1 and X2 are said to be linearly dependent if one can be expressed one can be expressed as a scalar multiplication of the other. Otherwise means if it is not possible to express like that, they are linearly independent. Otherwise they are linearly independent. If it is possible to express one vector is constant into some other vector, then they are dependent. If it is not possible, then they are linearly independent. This is comparison method. This method is comparison. One vector you can compare with other vector, whether scalar multiplication is possible or not, when two vectors are given. When two vectors are given, you can compare easily. Last slide. This one, definition. Note down. Completed. Whenever two vectors are given, we can compare easily whether one vector is possible to express scalar multiplication of other or not. Okay. Now suppose if they have given 3 vectors or 4 vectors or 10 vectors or n vectors, then how to compare? Examining all possible combinations consumes time. That's why what we have to do, we have to arrange all the given set of vectors in a matrix. Okay, concentrate here, please. Very, very important concept. Arrange all 10 vectors in a row or in a column, no problem. Arrange all the vectors in a row. Suppose your matrix is 10 cross 10. So your 10 vectors, each vector of dimension 10, then automatically your matrix will be 10 cross 10. Okay. So what you have to do, you have to reduce all the row vectors into echelon form by using elementary operations. You know the procedure. Till now you have learned. After reducing all the elements, all the rows by using echelon form, if you reduce into echelon form, number of non-zero rows gives us rank. Suppose I have given 10 vectors, you have arranged in a matrix, reduced in echelon form, you got rank 10. Sir, what does it mean? If rank is 10, you can understand that all the given set of 10 vectors are linearly independent. Sir, how can you say that? How can you say that 10 non-zero rows gives 10 linearly independent vectors? Suppose I got, after reducing in echelon form, if I found that there are 7 non-zero rows, 3 zero rows, then what? If you have 7 non-zero rows, you can say that there are only 7 independent vectors. Rank declares number of independent vectors. Sir, what is the logic behind number of non-zero rows and number of independent vectors? Simple logic. If a row become zero row. Sir, how a non-zero row become zero row? After applying operations, if you get 7 non-zero rows and 3 zero rows. I already told you at the beginning of the lecture, I already told you each row represents a row vector. Matrix is not only arrangement of elements but also arrangement of vectors. Catch my point? So in your arrangement, you have 7 non-zero rows and 3 zero rows. Simple logic, man. If a row becomes zero row means how it become a zero row? By applying some operations, na? By applying some operations or not? Suppose you have applied one operation R10 minus 5R1. Simple. If I apply the operation R10 minus 5R1, suppose if I got 10th row is zero row. How it become zero row? By applying this operation. Na? What is that operation? R10, 10th row minus 5 times of R1. 10th row can be expressed as 5 times of R1 or not. A row vector is expressed in the form of scalar multiplication of other vector or not. So 10th row is 5 times of R1. R1 and R10 are linearly dependent. That's why 10th row becomes zero row. Catch my point? So a row becomes zero row means by applying operations, a row becomes zero row means it is a dependent row. Okay, it is a dependent row. That's why by applying operation, that row becomes zero row. That's why always we are going to count non-zero rows to understand rank of the matrix. That's why we are counting non-zero rows. Understood? In echelon form, reducing the matrix in echelon form, count number of non-zero rows. Why you are counting number of non-zero rows? Rank represents number of independent vectors. Non-zero row is always represents independent vector because by applying an operation, by applying so many number of operations, a row is maintaining still as a non-zero row means it is a independent row. Catch my point? That's why you have to count number of non-zero rows to understand rank of the matrix. Actually, I have explained dependent and independent concept only by comparison. Only one definition is completed. You have total 4 methods. So 3 methods we are going to discuss tomorrow. Okay? Any queries? Some students have questions. सिमेट्रिक मैट्रिक्स, सिमेट्रिक मैट्रिक्स में भी क्वेश्चन है. Yes, it is symmetric. Next. अनिकेत, ये क्यों रिवर्स ऑर्डर में भेज दिया आपने? Sir, what is physical significance of rank? Got the clarification? What is physical significance of rank? Rank represents number of linearly independent vectors. Sir, if there is a zero row in between, then negative sign will come out. Never come. Ravi Ranjan, while finding rank, if you interchange two rows, you never come. If you interchange two rows, while finding rank, you should not change the sign. You should not. In determinant, whenever two rows are interchanged, you have to multiply with -1. Only in determinant, not in rank. Mr. Shubham, only in determinants, if you interchange two columns, you will get negative sign, not in rank. Okay? Not in rank. Rank of A plus B less than or equal to rank of A plus rank of B. Give an example. You take two examples, no problem. A, B, 0, 0, 1, 1, 1, 3, 0, 0. This is A plus B. This is A. This is B. Rank of A, 1. Rank of B, 1. Rank of A plus B. Add both. 1, 3, 1, 1. Rank of A plus B is 2. 2 equal to 1 plus 1. Next. Suppose A is 1327. B is 1056. Okay. A plus B is 1 plus 1, 2, 3 plus 0, 3, 2 plus 5, 7, 7 plus 6, 13. Rank of A plus B, 2. Rank of A, 2. Rank of B, 2. 2 less than 2 plus 2. Okay? Next. Can we convert any matrix in echelon form? Yes, you can convert. Sir, what will we get after knowing the number of independent rows and vectors? Mr. Ankit Sharma, if you know number of independent vectors, you can understand what are the independent variables. That is next concept. If how many are independent variables, how many are interdependent variables? Okay. Can we convert into any matrix into echelon form? Yes, you can convert. Verify the example. I have given all example. 2 examples I have given on this property. Okay. Good night. Tomorrow we can continue with linearly independent vectors, dependent vectors, basis, dimension, right? Thank you. Just I am giving the contact details. You can send me the message. I will add you in the Telegram group. No problem. Okay, thank you, good night. Mr. Sandeep, your matrix is 4 cross 2. No problem, you can create. I never said right angle triangle. I said you can create. Suppose you have 4 cross 2, 4 rows, 2 columns, 3, 4, 3, 5, 7, 2, 7, 6. Okay, form a right angle triangle like this. It covers one element, two elements. Okay, reduce all the entries covered by this right angle triangle. Thank you. Good night.